Good evening, students. Welcome to Students Accuracy and Demand Sets class. Welcome back. Yes, today we are going to discuss about a very interesting point, and that I don't want to mention because it is already written and you must have already known, and you are watching this video also after knowing that what we are going to learn. Yeah, correct. Diagonals. Number of diagonals. Correct. So it's an interesting point, isn't it? So you must see this video from very beginning to the end, otherwise this interesting topic you will miss. You won't be able to understand because there are many facts, many informations you'll be getting throughout the video. So if you skip those informations, you won't be able to understand the sums also, how we are going to derive it. So you must watch it fully from the very beginning to the end of the video. Don't skip. Next, I definitely hope that you would like this video. And of course, if you like this video, definitely you will press the like button as well as you will share it with your friends. Please do it. And also, don't forget to subscribe to One's class, this channel. See, there is a red button, rectangular button. Subscribe is written. Please press that, and don't worry, it's free. Many people think that if we put subscribe and some amount of money has to be paid. No, you don't have to pay a single penny for this. Just simply, you have to do take your finger and press that subscribe button, nothing else. Okay? Chalo. Now, let us start our topic to be discussed today. Our topic is number of diagonals. How to understand, how to find out, how to calculate the number of diagonals a polygon can have. So here 2 points, 2 terms are arising. One is diagonal and number 2, polygon. Both of them we have to understand first. So I'll explain you about polygon afterwards. First, let us understand diagonals. What is a diagonal? A diagonal is a line segment. A part of the definition I'm telling you, so that you can understand quickly in easier language. I'm trying to explain you. What is a diagonal? A diagonal is a line segment. Up till here. Okay. Now, what is this? This is a point, and the point is always denoted by a capital letter. Sir, you were talking about a line segment, a diagonal. You are talking about a point now. Yes, of course. As soon as this term line segment enters into our ears, which concept arises into our brain first? How a line segment is formed? A line segment is formed means when 2 distinct points are joined, a line segment is formed, isn't it? So here, sir, only 1 point you have done, and in that case, can we draw a line segment with the help of this single point A? No. We cannot draw a diagonal or a line segment with the help of a single point. For that, at least 1 more point is needed, isn't it? So, let us stop the discussion of what is a line segment and a diagonal. Let us first draw a diagram of a polygon. Line B, C, D. Now, this is a quadrilateral. Now, quadrilateral is also a polygon. Now, the point is, what is a polygon? Polygon means a closed figure made up of 3 or more than 3 straight lines, not curved lines. So a triangle is a polygon, quadrilateral is a polygon, pentagon is a polygon, pentagon having 5 sides, hexagon 6 sides, heptagon 7 sides, octagon 8 sides, like this, nonagon, decagon, it will continue. Okay, so these figures are called as polygons because they are made up of multiple straight lines, means not actually should be 3 or more than 3 straight lines. So now diagonals, as I was talking about, so a diagonal can be drawn from one point. A diagonal is a line segment that is drawn from one point to the other point, one vertex of the polygon to the other vertex of the polygon, skipping the neighboring vertex. Just neighboring vertex. If we move from this side, see, we are starting the diagonal from this point A, skip this point B and go to point C. Okay, and same way, if we move this side, here also what we will find, from A we are drawing the diagonal, we are skipping the next neighboring vertex and going to the next one. So, what is a diagonal? A diagonal is a line segment formed by joining 2 points, 2 vertices. Vertex is the singular, vertices is the plural. So a diagonal is formed. A diagonal is a line segment formed by joining a point of a quadrilateral or a polygon by skipping one vertex, neighboring vertex to the next one. For point B also you can see, if we start drawing the diagonal from here, what we will do? We will draw the diagonal from here to here. Why? Because we are moving from this side, suppose. Then we will start from B but skip C and come to D. Similarly from C, if you go, you will draw a diagonal from C. If this side, if you are moving, skip D, come to A, join this. Okay? From D, if you are moving this side, start from here, skip this A, join here. Diagonal is formed. So from each vertex like this, we can draw diagonals. Clear? See, for pentagon, suppose I am showing you a pentagon. See, A, B, C, D, E. Suppose from this side you are moving, from A you will start, next B is the neighboring vertex, skip this vertex, go to this, join them. From this side if you move, from A you are starting, skip this neighboring vertex, join the next vertex. Similarly, from C to E, C to A, from B to D, B to E, like this you will continue. So we are not, we'll talk about it afterwards. Let us finish up this first. Now here, what is a polygon we have understood, even what is a diagonal that also we have understood. Now, let us again go back to the definition of diagonal. A diagonal is a line segment, and a line segment is possible only when 2 different points are joined. So, can we draw a diagonal from A to A? No, we are staying in the same point. A line segment is not formed, so obviously a diagonal is not formed. So from A to A is not possible to draw a diagonal. From A to B can we draw? Just now I said in definition, skipping the neighboring vertex. So what is the neighboring vertex of A? B is the neighboring vertex. Even D is also the neighboring vertex. So AB is also not a diagonal and AD is also not a diagonal. So how many options we are skipping? AA, AB, AD. 3 options we are missing. We are skipping. We cannot draw a diagonal. So out of the 4 sides, we can say 4 minus 3. We have 4 sides. So from 4 sides of the figure, we are subtracting 3 options. Why? From A to A, we cannot draw a diagonal. From A to B, we cannot, as because we have to skip one neighboring vertex of this point. And here also same thing. Okay, so 1, 2, 3. 3 options are missed. We cannot. They are not possible. So 4 minus 3. Same thing will be here. 4 minus 3. Why? Because in this case also, if we draw, see, 2 lines and 2 colors I am showing, that means 2 diagonals. No, it is not correct. Only 1 diagonal. But I am showing you that if from this side we can draw a diagonal, then from this side also we can draw a diagonal. Reverse side. Yes or no? So every diagonal can be drawn like this. Every diagonal can be drawn like this. So each diagonal is double, means twice they are repeating. So 4 minus 3 here, 4 minus 3 here. So we will add up 4 minus 3 plus 4 minus 3, sorry, plus 4 minus 3 plus 4 minus 3. Now students, repeated multiplication, 4 plus 4 plus 4 plus 4 plus 4. Same number is being added repeatedly. What is the shortcut of that? How many times? 4 is being added 5 times. So 5 times 4 equals to 20. Same thing. 4 times 4 minus 3 is being added. So it will be 4 into 4 minus 3. Yes or no? Okay. Now each diagonal is being repeated twice. Isn't it? But that is not correct. So bring down the correct picture. Divide it by 2. Same thing here also we will divide it by 2. So what will happen? 4, you will cancel 4, 2. So it will be 2 into 4 minus 3 is 1 equals to 2. So actually, how many diagonals can we see in a quadrilateral? Only 1 and 2. Clear, students? You have understood? Now let us move on to the next diagram. Now students, you see. What is this? This is a pentagon. It is also a polygon. Okay. Now, from A, let us start drawing a diagonal. From A we will start, from this side we will move. In that case we will skip E, D. Then from this side if we move, skip this, go to this. Okay. Here also, if start from B. Acha. Now here, let me show. How many diagonals we have drawn here? We have drawn 2 diagonals. 1, 2. So how many sides are here? Pentagon has 5 sides. So it will be 5 minus. See, A to A we cannot draw. A to E we cannot draw. A to B also we cannot draw. Can we? No. So 3 options again gone. So 5 minus 3 here for A. Now from E to B, from E to C. How many we have drawn? 2. So therefore here again E to A we cannot draw a diagonal, E to E we cannot draw a diagonal, E to D we cannot draw a diagonal. So here also out of 5, 3. Okay. Now let us start from D. D to B, 1 diagonal, and D to A is already drawn. So those diagonals which are already drawn, I am showing them with another color. Okay. So here also, from D also again, 5 minus 3. Okay. Now let us start with C. From C to D we cannot, C to E, it is already drawn, and C to A is also already drawn. So here 5 minus 3. Clear? Now B. From B to D already drawn, from B to E already drawn. Now here also same, 5 minus 3. Why? From B to B we cannot draw, from B to A also we cannot draw, from B to C we cannot draw. So 3, 3, 3, 3, 3 have been subtracted from all 5 number of sides, from all the vertices. Okay. Now, very interesting thing you will have to see here. You will notice. See, each diagonal has been shown with 2 colors. That means they are repeated twice. Each diagonal has been repeated twice. So here, same thing as we have done before. 5 minus 3 plus 5 minus 3 plus 5 minus 3 plus 5 minus 3 plus 5 minus 3. How many times? 1, 2, 3, 4, 5. Divided by 2, as because each diagonal has been repeated twice. So finally we will have to divide it by 2 in order to bring the correct picture. So equals to repeated multiplication. So 5 into how many times? 1, 2, 3, 4, 5. So 5 into 5 minus 3 by 2 is equal to 5 into 5 minus 3 is 2 by 2. How many diagonals we can draw? 5. See. 1, 2, 3, 4, 1, 2, 3, 4 and 5. Total 5 diagonals can be drawn. Once again let me show you, it has become clumsy. 1, 2, 3, 4 and 5. So 5 diagonals can be drawn. Clear? Now let's move on to hexagon. अच्छा चलो octagon. 1, 2. Octagon means 4, 4, 8. So A, B, C, D, E, F, G, H. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So from A to G we will draw. Now as because this has been already drawn, so naturally we will have to skip. If we start from A, 1 we have skipped and we got. Now after this diagonal has already been drawn, naturally we will have to skip this also. We will move on to this. Then this is finished, we will move on to this. This is finished, we will move on to this. This. But A to B we cannot. So how many diagonals we have drawn? 1, 2, 3, 4, 5 from A. But how many sides are there? 8 sides. From A to A we cannot draw, A to H we cannot draw, A to B we cannot draw. So therefore 8 minus 3. Clear? Now from B let us start. B to B we cannot, B to A we cannot, B to C also we cannot, but B to D, B to E, B to F, B to G and B to H. Clear? Let us start C. C to C we cannot. So here 8 minus 3. So C to B we cannot, C to D we cannot, C to C also we cannot. But C to A has already been drawn. So let us use red color. This is drawn. Now C to H, C to G, C to F, C to E. Clear, students? Now here what happens? Same thing. 8 minus 3. Like this you will find, as because so many other, let me see, start from D also. So see D, D to C we cannot, D to D we cannot, D to E we cannot. So again same thing it will happen like this. D2, that is 8 minus 3. Here also it will be 8 minus 3. 8 minus 3. 8 minus 3. 8 minus 3. So now see, Let me show. D to B has already been drawn. D to A already has been drawn. D to H is not drawn. D to G, D to F. Okay. Now let us start E. E to G, E to H, then E to A drawn, E to B drawn, E to C drawn. Now F. F to D drawn, F to C drawn, F to B drawn, F to A drawn, only F to H is left. F to H is left. Okay. Now F also finished. Now G. G to E finished. G to D finished. G to C finished. G to B finished. G to A also finished. So every diagonal has got two colors, isn't it? So same thing. How many times? 8 minus 3 plus 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 8 minus 3. 1, 2, 3, 4, 5, 6 plus 8 minus 3 plus 8 minus 3. A to G, H. A, B, C, D, E, F, G, H. 8 by 2. Each are repeated twice. So is equal to 8 times 8 minus 3 by 2. Is equal to 4. 4 into 5 is equal to 20. So how many diagonals can be drawn? 20 diagonals can be drawn in an octagon. 5 diagonals can be drawn in a pentagon. It is an octagon. 8 sides, 8 vertices. This is a pentagon. 5 sides, 5 vertices. Clear, students? Now, if suppose, so these are all very simple. Suppose somebody comes at random at your house and tells, okay, you have understood up to octagon, okay, chalo, nonagon, decagon, chalo. They are having maximum 10 sides, 11 sides, 12 sides. Forget it. Tell me the number of diagonals a polygon of 100 sides will have. In that case, sir, what to do? Simple. Here, sir, 100 times we will write. No, you will write 8. This is an octagon, 8 into. This is a pentagon, 5 into. So, when in case of 100, so 100 into how much? 100 minus 3 by 2. Simple, students. Number of sides, 8. 8 minus into 8 minus 3. Number of sides, 5 into 5 minus 3. Number of sides, 100. 100 minus 3. So equals to, cancel it. Cancel it. 50. So 50 into 97 is equal to 5 sevens are 35, carry 3, 5 is 45, 4, 8, 5, 0. Number of diagonals, a figure of 100 sides will have. Sir, 100, it's a very simple one. It's carrying only 1 and 0 and 0. So suppose if it is 1, 1, 2, 4 sides, then in that case, suppose, sir, let it be an odd number. 1, 1, 2, 3. Okay, 1, 1, 2, 7. So, simple. 1, 1, 2, 7 sides. 1, 1, 2, 7 sides. The polygon has got 1, 1, 2, 7 sides. So let it be into 1, 1, 2, 7 minus 3 by 2 equals to 1, 1, 2, 7 into 1, 1, 2, 4 by 2. 2, 5s are 10, 6 are 12, 2 to the 4. So equals to 1127 into 560. 62, you have to multiply. This much labor you have to give. 2 sevens are 14, 2 2s are 4, 5, 2 1s are 2, 2 1s are 2, 6 sevens are 42, 6 2s are 12 plus 4, 16, carry 1, 6 1s are 6, 7, 6 1s are 6. So there are 42, carry 4, 6 2 are 12, 24, 15, 16, 42, 6 2 are 12, 16, carry 1, 7, 6. Chalo. Next, 5 sevens are 35, carry 3, 5 2s are 10, 13, carry 1, 5 1s are 5, 6, 5 1s are 5. Add up 4, 7, 8, 13, carry 1, 11, 13, carry 1, 13, carry 1, 6. So, a figure having 1, 1, 2, 7 sides will have 6, 3, 3, 3, 7, 4 diagonals. Understood? Now, this has to be converted, this concept has to be converted into a formula concept. Generalized formula. How? Now here, what we saw, number of sides into number of sides minus 3. Number of sides into number of sides minus 3 by 2, by 2. Number of sides into number of sides minus 3 by 2. So let number of sides be n. In that case it will be n minus 3 by 2. Finished. So if somebody asks you what is the formula of a polygon of many sides, you will say, if let us assume that the number of sides is n, in that case n into n minus 3 by 2 is equal to number of diagonals, is equal to number of diagonals. Am I clear, students? So if somebody asks, how many diagonals would a nonagon will have? Or a decagon, let it be decagon. Decagon means 10 sides. So 10 into 10 minus 3 by 2 is equal to 5 into 7, 35 diagonals. Finished. So I hope it was a new thing you have learned. I think it is starting from class 8 in CBSE. So please, you can form your own figures and do this calculation. I hope you will be able to understand and you will be able to do better by yourself instead of depending on others. Okay? Probably you have liked it. So please, thumbs up, press the thumbs up. Press the thumbs up button and share this with your friends. Let them also learn. Okay? And please subscribe to my channel. Okay? Good night.